YouTube. All right, gentlemen, we're live.
All right, woo, here we go.
Hey, everybody.
Yeah, welcome back to This One Time. Today's episode is going to be a fun one. We're talking about a project that we just buttoned up. Was that a couple days ago?
Yeah.
Something like that. This is a little quick turn project. The title of today's episode is Reviving a Relic. We're going to talk about saving old equipment from I guess oblivion.
Yeah.
The
scrapyard, perhaps.
The scrapyard, yeah. So we're going to get into that. Quick recap at This One Time. We're talking about our journey through hardware development here at Urban Machine. At Urban Machine, we're building a system and a robot to recover, reclaim waste lumber from the construction and demolition industry, put it back into use. And you always hear the hardware is hard. I say this every episode, but you don't hear the details of that. Like a lot of details kind of get swept under the rug. So we're here to put that on display. We're kind of doing some of our building in public, hoping to engage folks, and maybe there's some nuggets in here, some of the things we're talking about maybe resonates with some of the folks out there, and maybe it helps them reach their goals a little bit faster, just help everyone move down the field towards their goals a little bit further. Yeah. So today, Tyler Compton on the podcast here. Tyler is key member on the software team. First employee.
That's right.
Yeah, that's right. Been here right from the very beginning. And we're gonna talk about reviving a relic today. It's a sort of a hardware software combo project. So I guess should we just get into it?
I think so.
Okay. All right.
Good to see you guys.
Yeah, good to see you, Jorie.
Mhm.
Yeah. Sorry, I completely didn't introduce you.
No, that's okay.
Yeah.
That's all right.
Jorie Wisnefski, our marketing manager here at Urban Machine, leading the charge with me on This One Time, doing all the heavy lifting, getting it going.
Trying to learn about what you guys do over there and
Yeah.
spread the good word about your amazing engineering team and what we do here at Urban Machine.
That's right. Yeah.
All right, so you guys obviously had to have a metal detector in order to make sure that the wood is indeed metal free and ready for reuse. One of the things that's made me laugh whenever we bring demo robot anywhere, people ask about that quality control component, right? And I explain that we do have a metal detector at the end, and inevitably someone, at least every fifth person, tells me about that they have the wand, and that's how, after they pull the metal out by hand and it takes 2 weeks to do 3 boards or whatever, something ridiculous, then they have like the metal detector at the airport with the wand, and then they bring it to the mill, or they run it through a planer on their own or whatever, and the wand didn't work. And I was like, nope, this is a serious metal detector. This is not the wand.
Yeah, we got the real
On
deal.
Amazon.
Yeah, the challenge with the wands is that you really only have a detection range of maybe a couple inches around the end of the wand. So, if the wood has a screw, a broken off nail or something that's a little bit deeper in there, or if you're not just extremely diligent about basically rastering the wood with that wand, really, really easy to miss stuff. So we actually have gone through sort of 2 generations of metal detectors, and maybe should I just share the image of the first one and start telling its story?
Yeah, for sure.
Yeah.
How did you guys get this first one?
So this one is the Relic.
Right.
This one was, according to the tag on the inside of it, born in 1985, and it was used in the lumber industry for scanning logs coming out of forests. So the idea with this is that you drop your log on this conveyor belt here. And even logs out of forest can have metal in it. Like there could be like pieces of a fence or bullets. Like we've been to lumber mills where they have sort of like a wall of fame of things they found in virgin lumber.
Yep.
So they like to scan this stuff as well. And there's really nothing better than just passing it through a giant coil. It's really the only way you can guarantee there's nothing in there. So we um,
I mean, of
we
course, if
found
you're
more.
just side note, absolutely having nothing to do with anything but the aesthetic. Green and yellow. My husband is from Wisconsin, so he's
Yeah, is that
Yeah, this is
hackers colors?
Yeah, this is
Like-
hackers metal detector.
it's happy colors. And of course, making a gunshot.
Sorry, Joey, we're losing you a little bit.
In log in Wisconsin. Okay, sorry.
Right. Yeah. So this we actually found as used equipment. It was on like basically an equipment liquidator's website in Tennessee, I think. So we found it for sale. It had been basically retired out of service, but perfect for us, perfect for our application. So we bought it from them, and had it shipped out to California. And we put it online, and it was basically like we plugged it in, and it was like, yeah, it was good to go. Yeah, more or less, no issues with this thing. We were running it pretty simply though. We were basically just like dropping material onto the conveyor and running it through
Okay.
as a kind of a standalone unit.
Mhm.
Um,
This is very early on before we had our process really nailed down.
yeah, yeah.
And it was
As our
consistently finding the metal, though.
Oh yeah, yep,
Yeah.
consistently finding metal, doing its job. As our process became more sophisticated and we wanted to improve integration with our picking, that's when we sort of evolved this to the next design. Also, we obviously want to design our process to scale, and these things aren't exactly off the shelf. There's not a deep supply of used metal detectors from Tennessee.
Yeah, not a house full of these.
Yeah, exactly. So this kind of made its way into the, as we developed a new system with modern components, this kind of made its way to the corner of our shop, and kind of was just collecting dust for the last year or so. Um, More recently, we found a need for it, and we thought, okay, well, we actually want a conveyor system feeding material into the robot. And this is like a perfect heavy duty conveyor that we already had on hand. Um, One interesting thing about conveyor systems that is probably surprising for folks just getting, conveyors are very expensive.
Mm.
Like a conveyor of this, like a heavy duty conveyor like this designed to operate outside, 12 feet long, sort of like 2 foot wide belt. A conveyor like this off the shelf new is probably around somewhere between $8,000 to $10,000. And that's not integrated. That's like basically just like showing up with a couple of wires that you plug your motor into. Pretty pricey. Um, we thought, okay, why don't we just get this thing out of the corner of the shelf, and we'll use this as our in-feed conveyor while we get going. And you know, we like to talk about problems on this one time. So the first problem that we ran into with this thing is the control over the conveyance itself, right? Is these old or most conveyor systems have just like old school AC motors driving them. They happen to look like this.
Okay.
So this is the motor that came with this conveyor. This is a three-phase AC motor. It can run at either 230 or 460 volts. It's pretty power hungry. It's a 5 horsepower AC motor. This is huge. It might not come across in the table, but like you can like this thing probably weighs like over 50 pounds or something like that. Like it is burly. It is huge. It's also kind of tricky to control. If you want to do the kind of fine motions that we want to do with our system, you have to go out and buy another piece of equipment. They're pretty ubiquitous in the industry. They're called a VFD, a variable frequency drive. Um, And that allows you to change the frequency going to the motor, which eventually, like works out that you're changing the speed of the motor. And the VFDs can cost as much of the motor itself. And that was our first approach for this, right? Is we plugged in the VFD. And then, but that was where the problem started to come up. Do you want to elaborate on the problem with the VFD control pathway?
You said with the VFD that with the frequency modulation, the motor starts moving eventually, and
Yes.
it eventually was definitely our experience. It seems like at least with this combination of motor and VFD, we got very kind of lethargic movement from the motor. It would, we'd get a very noticeable, I don't know, what was it, like half second to a second, like delay between us telling the VFD, go, start moving the motor, and the motor actually even beginning to accelerate. And not only that, we also had some, but rather limited control over like acceleration profiles and all of that. And the reason why this is important is because we wanted to sync this conveyor belt with the rest of our wood conveyance system, which is a combination of another conveyor belt and these spiked rollers that we use for moving wood around. If they are not synced up, it's much harder for us to understand where the wood is in the system. So it became clear pretty early. We were trying to kind of hack around and compensate for this delay, but it was just, it wasn't working out. And it became pretty clear to us that this pretty old school like AC motor VFD combination just did not have the precision that we needed to move the wood in the way we needed.
Okay.
Yeah.
So you're all on board for this. And where do you head from there?
Yeah. So this is when we reached out to a supplier of ours that they build brushless DC servos. Company's called Technic, and the product line is ClearPath. And we already use a bunch of Technic products and the rest of the robot. They've been great. They're sort of like maybe you could consider them like a mid-tier, like not quite industrial servo, but like really they pack a pretty tremendous punch. And they offer AC motors that are far more performant than relics like this. You have basically full control over them. Like they have a huge amount of intelligence built into them. And they're more or less plug and play. Like you can buy them off the shelf and you can just swap it in for a motor like this. And it's pretty much ready to go. So you can really just kind of get in there and it's almost just like a heart transplant or something like that.
Yeah. You said that in your note to me. I thought that was pretty appropriate.
Yeah. So here's the ClearPath motor. Yeah, and it's quite a bit more nimble. It's also far more energy efficient than the old one. So
this is is this brand new or?
This is brand new.
This one's brand new.
Yeah.
Okay.
Yeah.
And size wise?
It's quite a bit smaller. It's probably like half to a third of the weight.
Oh, okay.
Of the other one. Yet it can do its peak output. You can run it on single phase 230, and its peak output is actually higher than the other one. Its peak output is around 7 horsepower. So like it's smaller, lighter, easier to control, and far more powerful.
Easier to power too.
Packages.
Yeah, apparently, especially after 40 years or so, we've come a long way in terms of motor design.
Yeah, exactly.
Yeah, the 3-phase part of the old motor was a big problem too. Finding 3-phase power in our vertical where we, just go to random like job sites and stuff can be quite tricky. So having something that just runs on regular wall power, or I suppose it's 240 volt, but something very close to regular wall power is very beneficial.
And you can actually run this off of 120 wall plug as well if you wanted to. Yeah, you can configure it that way. And you're not getting quite that 7 horsepower peak when you do that, but you can still run it off of a 120 line.
Okay.
Yeah. Yeah. And so integration of this, it wasn't completely pain-free.
No.
Right.
What?
But, so it So yeah, we are kind of like right now we're very in the Technic ecosystem. We use their motors pretty much exclusively right now, and we also use their clear core. They're sort of like PLC microcontroller hybrids built specifically for driving their motors. We've had a lot of good luck with them. The fact that we get that really tight integration is really helpful. It increases their ability to give us support. And so we thought, yeah, we're just going to drop this motor in and control it. In actuality, it was a little more complicated than that. These motors are supported by the clear core, but there's this kind of weird limitation that I was not aware of, where you can only combine control of our normal motors and this new AC motor in very specific ways. Like, without getting too into it, you can have like 2 of the normal motors, 2 of the AC motors, or 4 of the normal motors and 4 of the AC motors, and you can't really like mix and match much beyond that. So we found that out and we were like, crap.
Well, how did you find out? Like, what?
Yeah, so this is a great example of how like no matter how much you try to de-risk something, there's always some little gotcha. So we set up a benchtop test before we tried to integrate with the rest of the stack at all. We had a single clear core, and we had the firmware controlling this motor in an isolated benchtop test completely on its own, just to verify that we were seeing the response we wanted, the performance and the control. We were able to vary the speed within the ranges we wanted to. And then the benchtop test, it worked perfectly with a single motor plugged into it.
Yeah.
And then we're like, okay, great. So we should just be able to plug it into our other controller that's already on the robot and be up and running. And then the snafu, the like 2 versus 4, that's when it really got us that, our other controller already has 3 motors plugged into it. This is the 4th motor that doesn't match the control profile of the other 3. And the arcane details of the clear core only allows you to either do all 4 the same or 2 and 2 the same. It doesn't allow for 1 and 3. And that was the little gotcha there.
Yeah.
On that. That really, it's not until like these are the details of like the integration that are just these tricky cases that even when you try to go through the pain of a benchtop test, these little things still fall through the cracks.
Yeah. You're always going to be making assumptions even when you don't realize what those assumptions are. Turns out one of our assumptions was this, that we thought we could control this special combination of motor. Luckily, though, we did figure out a way around this. So it turns out this motor is very configurable. It allows us to control it in quite a number of ways, some of which are completely independent of the those clear core PLCs that we use. So we instead went with a system that allowed us to use just like regular pens on the clear core as opposed to the specific motor control pens, and control the direction using a digital signal and the speed using another digital signal, but using PWM. And that really saved us. That was one of those things where we were, we really wanted to wrap this up that day, right? This was supposed to be something easy. And me and Andrew were like sweating over the computer trying to configure this thing. And we found this option and we were like, oh, here we go. Before that we were thinking, okay, maybe we can't get speed control. Maybe like we'll have to rethink how we control this thing. But that was
trying to figure out what you could just check off the list and what had to be. So how'd you find the right combo?
Yeah, I think it's just sort of like you just almost run the triage process, just combing through the docs, combing through the menu, and just kind of trying to keep your, try to keep an open mind of like the possibilities.
Yeah.
Because we ended up doing this like, oh yeah, we can just drive the speed via PWM, and we don't need to use the motor socket on the control board. We can just use other IOs and just like pretend this is not a motor at all. This is just some regular digital output. And then we, a combination of that insight plus being able to drive the speed on the motor side with PWM, we can connect the dots in kind of like this out of the box thinking kind of way.
So this just made the difference.
That was it. Yeah. And then as soon as we did that, it was up and running. Yeah.
It was a successful heart transplant.
It was a successful heart transplant. Yeah, and this all took course, like this was all within the course of a handful of hours.
Yeah.
Like this is kind of like the timeline figuring this out. So like it was a little bit of a pain, but always these things like you think something is going to take 30 minutes, ends up taking a handful of hours.
Yeah. Nothing takes 30 minutes.
Yeah, nothing takes 30 minutes. There's no such thing as a 30-minute heart transplant.
Doesn't exist.
I think, I think that is a worthy statement. And
Yeah.
it doesn't surprise me though that even still it was something you guys did in a matter of hours instead of days.
Yeah, it was pretty successful, and we're super happy with the performance of this thing. Like it's been running in our line for the last handful of days now, and the performance difference between this and the old beast is just incredible. It's like it's amazing that you can, like, just by dropping in a new motor, take this this old relic from 1985, and have this like extremely precise control over the whole system.
Yeah. Yeah, it makes a lot of sense though. I mean, you think about anything that is streamlined, anything that's updated for the most part, right? I can't think
Yeah.
I'm trying to think of something that doesn't fit that bill.
You need something that got worse over time instead of better.
Yeah,
Big washers and dryers. I don't know.
that is a fair point because they don't last anymore for sure.
Yeah.
That is true. Or like the very first, dare I say, iPhone, like that thing lasted forever. Now they're a lot more complicated now, but
No replaceable battery in those new ones. So,
No.
You win some, you lose some. But I think,
Yeah.
by and large, in the industrial sector at least, it does seem like the progress is positive.
Yeah.
awesome.
At least for motors, certainly.
Yeah.
And this is exactly the type of story that, like this is the type of pathway that we love to find at Urban Machine, because we're all about circular economy, right? We're like all about sustainability. So there's a lot of life left in these machines that you find in these I'll call them graveyards for kind of lack of a better term. Like we've toured all sorts of these yards looking at Relic equipment and knowing that, like, okay, you can get a lot of life out of these things just like by massively upgrading them with a swap like this. You can get like a really modern, incredible control over something, and we're saving a lot of steel, we're saving a lot of remanufacturing, we're putting these things back into service. So that's like exactly like what we do. That's what we do here.
Yeah.
Yeah.
Absolutely.
Walk the walk, talk the talk, right? I love it.
That's
I
right.
think that's awesome. And far better than back to Wisconsin. Have you guys ever heard of a combine derby, a combine demolition? I can't think of the right proper terms, but they take old combines, relics, and it's a derby, and they smash them until the last one's standing. They just run the combines into each other. I had never seen such a thing until I started dating Mike. But it is entertaining, and then
Circular economy.
yeah, there's nothing
Yeah, for the last bash.
Uh-huh. Yeah. You'll have to go on YouTube, check it out. Combine Derby or something. I'll think of it.
It sounds fun.
Yeah,
I want to
too much
watch
fun,
it. Yeah.
Yeah. You root for the one that's like literally got like everything's hanging off of it and the guy's barely sitting on anything, but it's still going. You're like, oh, it's
Just
exciting.
eking along.
Yeah.
That's great. That's great.
Well, this was entertaining and interesting. I always learn a little bit of something from you guys, and I appreciate understanding just more about what you guys do and how your brains work. It's really fun.
Yeah, it's really
Learn
fun.
more about Urban Machine and how we are keeping circularity alive and taking wood waste and removing the metals robotically so that wood can be reused again as premium lumber. You can visit our website, urbanmachine.build. Andrew and I will be back in a couple weeks for another episode of This One Time where
Yep.
I learned something about the machine and the process of building it.
Absolutely.
Yeah.
Yeah.
Thank you, everybody.
Yeah.
Bye, guys. Thank you.
Bye bye.